Good afternoon all of you. Here we are considering assignment problem and discussing how to solve an assignment problem. This is a very interesting method which called the assignment technique, which is applicable to a class of very practical problems generally called assignment problems. The objective of the assignment problem is to assign a number of origins or jobs to the equal number of destinations or persons at a minimum cost or maximum profit. That is, to minimize the cost or time of completing a number of jobs by a number of persons, both are same. What is the mathematical form? Suppose there are in job small n number of jobs to be performed and small n number of persons are available for doing this job. Assuming that each person can do each job at a time, though with varying degree of efficiency, let Cij be the cost if the ith person is assigned to the jth job. Then the problem is to find the assignment, that is which job should be assigned to which person on a one-to-one basis so that the total cost of performing all job is minimum. And problem of this kind is known as assignment problem. So mathematically we can express minimize z equals to double summation I equals to 1 to n, z equals to 1 to n, Cij, Xij. Subject to summation xij equals to 1 and summation xij equals to 1 for j equals to 1 to n, here I equals to 1 to n, and xij will split it like xij equals to 1 if ith worker be assigned to the jth job and equals to 0 otherwise. Actually, assignment problem is done on one-to-one basis and the number of source and number of destinations are equal, hence the cost matrix must be a square matrix. And xij, the jth job is to be assigned to the ith person and can take either the value 1 or 0. The capacity and the requirement value here is exactly 1, that is for each source of each destination the capacity and the requirement value is exactly 1. The problem is unbalanced if the cost matrix is not a square matrix, and if it is not a square matrix then we have to add to dummy row and dummy columns with 0 cost matrix. Now here we've taken an example and the optimal assignment and minimum cost of the assignment with the following cost matrix. Here the cost matrix is given like that with 5 persons and 5 jobs. Since the number of rows and number of columns are equal, since it is balanced, first we are subtracting the minimum element of the first row throughout the row. That means 5 will be subtracted from all the elements of the row, then 1 is subtracted from all the elements of this row, then 8 is subtracted from all the elements of this row, then 9 is subtracted from all the elements of this row, and then 8 is subtracted from all the elements of the row. Then we get this matrix. This is called row operation. Next we perform the column operation, that means from the column choosing the minimum value and subtracting from all the columns from first column. Similarly, minimum value choosing for the second column and subtracting from all the columns. Since 0 is the minimum value, so same cost matrix will be there. After that, we have to determine minimum number of horizontal and vertical lines to cover up all the zeros in this resulting matrix, and minimum number of lines will be drawn that must be equals to order of the matrix, which is the conditions of optimality. Here the number of lines drawn is 4, which is not equal to order of the matrix, therefore optimality doesn't satisfy. Again, next what we have to do, next we have to determine smallest element from the uncovered element. These are called uncovered elements. From these uncovered elements, smallest value is 3. We are subtracting this 3 from the uncovered elements, that is from 12, 15, 5, 3, 5, 3, 7, 8, and adding in the junction, that means 8 plus 3, 1 plus 3, 6 plus 3, 0 plus 3, and this is the resulting matrix. And in this resulting matrix, again we are drawing the minimum number of horizontal and vertical lines to cover up all the zeros. And now the number of lines equals to 5 and the order of the matrix is 5, therefore optimality has been satisfied. Then we have to assign in this matrix the minimum assignment. Here what is we have to see that throughout the row or throughout the column, when we go through, we want to know if there is a single 0 is there. Through this row we have one single 0, so we can assign this 0, and corresponding column, if there is any 0, we have to cross off. And after that we should find any other 0 with single 0 row column. So this has no single 0, this has no single 0, no single 0, no single 0. Next we're choosing this column. We are choosing this column, we take again a single 0 here, so we assign this one, and corresponding to any 0 will be there, then we have to cross off. After crossing off this one, again we have to choose if there is any single 0 or not. There is, can't find any single 0. Next we have to use in the remaining zeros the trial error method. If we are choosing this 0 as a assigned value, so this will be crossed off and this will be crossed off. And if this is crossed off, in this column only 1 0 will be there, that should be chosen. And if this is chosen, this will be crossed off. And if this will be crossed off, this is already crossed off, so this will be assigned. So A is assigned to the job 2, B is assigned to the job 4, C is assigned to the job 5, D is assigned to the 1, and E is assigned to the 3. So this is my optimal assignment. After taking optimal assignment, we have to find out the minimum cost. We just put the original cost against the assigned position. For this one, original value is 5, then 1, then so on. So we have to add all the assigned jobs cost, and that is my total minimum cost. Thank you.